presentation from Professor Goffredo LaLoggia, another very, very current and hot spot topic. So Mediterranean maritime pollution, the role of remote sensing to monitor and mitigate. 15 minutes, please, Professor LaLoggia.
Thank you, Mr. Chairman, Mrs. Chairman. I'm going to speak about the pollution of Mediterranean Sea and the role of remote sensing that we use to monitor, and then coupling remote sensing with mathematical modeling, we can be allowed to mitigate. There is a need to monitor maritime pollution that is due to human activities that contaminate both coastal zone and the open sea. And so, as I said before, we use to face pollution integrating remote sensing, hydrodynamics, and biooptical modeling. As we may know, coastal water pollution is related to land activities because 60% of world's population lives within 60 kilometers from the coastline, thus impacting water quality. We have also an over-application of pesticides and fertilizers. And so we may see a coastal zone algae growth, an alteration of natural food chain, and a deprivation of the oxygen by coastal waters. Moreover, we have also offshore pollution related to maritime oil transport. We have in our sea, in the Mediterranean Sea, a quarter of global maritime traffic that causes about 7% of world oil accidents during the last 25 years. And we have also a biological impact on open sea and on coastal zone habitats. We can make a distinction between coastal areas with lagoon and lakes and the offshore parts. And here on this slide, we say a very quick example of some activities that our Medilab Mediterranean remote sensing and GIS laboratory has carried out during these years. We have studied for the inland waters toxic blooms like some rubescens algae, studying the different reflectance, and so we can make some monitoring using aerial or satellite sensors to monitor these blooms. But other studies we have made in offshore areas studying water quality, like surface chlorophyll and the turbidity, like you can see on these two slides, these images, and the other are related more specifically to the oil spill. This note deepens the results of a MAPRES research project that has been financed by European Community. That means marine pollution monitoring and detection by aerial surveillance and satellite images. We can describe the effects of large spills, as you can see during these days, but due on the heavy spill that we have in the Gulf of Mexico. And here on this slide, we can see some oil spill events that happened from March 1965 since December 2002. And there also we have a heavy localization on the area of the Mediterranean Sea. From the type of oil pollution, we can have some systematic, like the one due to industrial discharge, operative, like tank washing, bilge water discharge, and ballast water discharge, and the other accidental, like oil tanker accident, pipeline break, oil platform accident, oil terminal accident, as we can see during these days. on this slide, we can see how we have in the Mediterranean area a very, very high route of transport, and we have a big crossing of tanker traffic with oil transported in millions of tons. In Spain, we have had this accident on the 13th of July 2007, and the ship Don Pedro hit rocks and sank on Wednesday of the 13th July with 150 tons of fuel oil and 50 tons of gas on board. So we can see on these slides the Ibiza beaches with Talamanca, Figueretes, and Platilla de Bosa. And here we have another case of the Prestige on November 2002. And in this case, we can show how helpful can be an image or more image coming from satellites. This is a radar image acquired by an European Space Agency satellite. And we can see the shape of the thin film of oil on the sea. And based on this idea, we have also here a number of documented oil spills that have been detected in 1999. We have 1,638 spills detected in that year using a sensor equivalent to the one I've shown before, for one amount of 13,000 tons. And so here we have a brief description of our project. The project has been carried out by a cooperation between among Italy, Republic of Malta, and United Kingdom, and it lasted just 1 year, 12 months, on 2007. The idea was to detect an oil spill by using remote sensing, then to forecast the propagation of this oil spill by simulating by a hydrodynamic numerical model, and then to establish the procedures of mitigation when we have forecasted the area of the impact. And so a manual and guidelines coming from preceding tasks have been delivered for the project. And the results of this project has been this operating manual. So here you can see who was the coordination for the propagation, and the idea is to use an operational system for predicting the fate and transportation of this spill in the Malta Channel, and develop some models to detect the areas around the Maltese Islands, and Pozzallo is in Sicily. And in case of emergency, the models have to determine where will the oil slick move to, when will it get there, and what will be the state when it arrives. So here we have the links, the coordination among the different parts of the model. There's time is not enough to describe in a deep way how the situation is going to work, but the MAPRES project is the site is operative, and so you can download everything. So we have the forecasting. The forecast has been done by a nesting of different models at the different scales that you can see on these slides. So we have here the nesting of different models, and here we have the two models for Malta and Pozzallo. And here we have the very, very detailed model that we set in our department. And here you can see a comparison between the two models. When we use a coarse resolution or a finer resolution, you can see, you'll show here, how in the first case we don't see that the pollutant hits the coast, while in the second case on the right side we can see something better. And here we can see also the effects of booms that we set when we can forecast the precise orientation of our propagation. And so, at the end, we have made an exercise with the Comando Generale del Corpo delle Capitanerie di Porto, and we simulated a spill, and in the place near Pozzallo, we simulated a spill looking at 10 tons of petrol, in really were 2 tons of rice hull that was discharged into the sea, and using remote sensing coming by the surveillance of the Capitaneria di Porto, and also the mathematical model, we were able to simulate the spill and the fate of the spill. So you can see here the operational activity with the rice hull discharged into the sea, and here you can see the movement on the left part, on this part of the spill, and what we have forecasted with our model. So, and this is at the end was what what's remaining after at the end of the experiment. So this is all, and I hope to can share with you the information about the way in which we can mitigate pollution in maritime areas, putting together remote sensing and hydrodynamic modeling in order to forecast where the spill is going.
Thank you, Professor LaLoggia, also for being perfectly in time. The question is obvious. Do you feel confident it will be possible to overcome definitely the tragedy of the Mexican Gulf?
But the first problem is related to the quantity of oil spilled, and then to the. I know that oil in this moment is not coming at the surface, but it's remaining in the thermocline. So it will be very, very difficult to forecast the fate of this oil. And third, there's another question. When do they succeed in stopping the oil from coming out? So this experiment we have done in 2007, 3 years ago. So maybe we were
much less quantity.
Much lesser. Yeah.
Thank you very much. Yes, another question. Because everybody must be able to listen.
Please, does your model take into account also weather conditions? Because they can, of course, affect...
Yes, surely. The model has an input of the model. You have seen the nesting of different models, and those models are model forecasting for the sea conditions at the boundary. So we give to our model the very, very thin resolution one, the boundary conditions, and then the model has the wind at the surface, the wind that can obviously have effect on the oil. Yes.
Okay, thank you.
It's a completely three-dimensional model.
If not, thank you very much.